Alright, these are notes on O17, graphing linear inequalities. First things first, make sure you write O17 notes on the top of your notes so you know what section we're talking about. The following equation is in standard form. 2x plus 3y equals 6. It's something you've seen already before, where both x and y are on the left-hand side of the equal sign. In order for an equation to be in standard form, both the term with the x and the term with the y need to be on the same side of the equal sign. This also applies to inequalities. Here are some examples of equations and inequalities written in standard form. So 6x plus 3y equals 21. You see both x and y are on the left-hand side. 2x plus 9y is less than 17. That's also another example of standard form. And 4x minus 2y is greater than 100. That's also in standard form because x and y on the left-hand side are on the same side. And there's numbers on the other side of the equal sign or inequality that you can work with. Now that we're familiar with what standard form equation looks like, let's practice graphing standard form and standard form inequalities. So here's our first problem. Graph the following slope-intercept form equation on the graph below. Our equation is 12x minus 13y is greater than or equal to 78. So what we want to first do is we first want to find our x-intercept. How we go about finding our x-intercept is that we're going to take the term with the y in it and we're going to cancel that out. So we're going to put a 0 in for y. So the term with the y disappears, just like how I made it disappear. So our equation now is 12x is greater than or equal to 78. If I want to get x all by itself, I have to divide by 12 to both sides. So I then type in 78 divided by 12 in the calculator, and I get 6.5. So my x-intercept is 6.5. Now to find my y-intercept, I put a 0 in for the x value. 12 times 0 is 0, so that disappears. And what I have left over is minus 13y is greater than or equal to 78. So you do minus 13y is greater than or equal to 78. We divide both sides by negative 13. And type into the calculator 78 divided by negative 13, and we get negative 6. So our y-intercept is negative 6. Now if I like to graph them once after I wrote them down. So x-intercept is 6.5, so I go on my x-axis and I go to 6.5, which is located right here. I'm going to put a dot right there. My y-intercept is negative 6, so I go plot a point or a coordinate at negative 6 on the y-axis. Now, to determine if something needs to be a solid line or a dashed line, we look at the inequality. If there's a line in the bottom of that inequality, the meaning we're equal to, then we're going to make a solid line. So in this case, we have here greater than or equal to, so it's going to be a solid line. So I'm going to make that right now. Make it green. So you see a solid green line with arrows on both sides. Now, because we're working with an inequality, we have shading. Shading is involved. So they're saying both x and y is greater than or equal to 78. Now there's multiple ways you could do it, but the one way I like to do is I always like testing the 0, 0 coordinate. Meaning I want to test the origin to see if this side of the green line over here is supposed to be shaded or if it's supposed to be on the other side. So if I put 0, 0 in and it tells me a true statement I want to shade the true side opposed to the false. So if I put a 0 in for x, and I put a 0 in for y, 12 times 0 is 0, minus 13 times 0 is 0. Is 0 greater than or equal to 78? No, that's not true. Since this is not a true point, that means the other side of the line that we drew is where all the true answers are.